So let's go back to this problem
All right.
and try working this out. Let's call these 12 moles and 12 moles. And the question is, how much ammonia can we produce if we start with 12 moles of each starting material? Did you get an answer? Where's your work for that? Over here? Or, yeah, over here.
Start with 12 moles of hydrogen gas. Is that not correct?
No, that's good.
Okay.
Check your math there. Okay. So those are good steps, but what's the answer to the question then? The question was, how much ammonia gas are we going to be able to produce if this reaction goes to completion?
You add them up.
Add up which two numbers?
The moles of NH3 that each one produces.
Actually, that won't give us the right answer, so let's think about that again. Now, this reaction is going to completion, so remember our trick was to find the limiting reagent. We had to figure out what the limiting reagent is. Well, what have we figured out? Who is going to be the limiting reagent in this problem?
The H2.
Yeah, the H2. Okay. So what's this change going to be? How much H2 are we going to use up?
Minus 12 moles.
Does that make sense, or is that wrong?
Yeah.
Yeah, that's right. All right, minus 12. Okay, and then how much of this are we going to produce?
8.
That's what you really figured out down here. So how much ammonia do we get?
8.
Right. So that's the answer. We don't add that to the 24. Remember, this is how much ammonia we could get if this was the limiting reagent. And this is how much ammonia we could get if the hydrogen was the limiting reagent. So those are not combined scenarios, they're mutually exclusive scenarios. One will be the case or the other will be the case, but not both. In this case, we decided that we were going to run out of hydrogen before nitrogen, so we can't get all 24 moles of ammonia that we could get if there was if the nitrogen gas was the limiting reagent. It's like in the last example with the sandwiches. We figured out that we could get 5 sandwiches from the bread and 10 sandwiches from the salami, but that didn't mean we got 15 sandwiches overall. It meant we only had enough bread for 5 sandwiches, so we had to stop after those 5 sandwiches. We didn't add the 5 and the 10. Okay, so this would end up giving us the number 8. This might be a little clearer if we figure out how much nitrogen gas we're going to use up in this reaction. So let's figure out how much nitrogen gas will be used up in this reaction. We want to know how much nitrogen gas will be used up if this reaction goes to completion. Yeah, those are good target units. Now we have to figure out what our starting information should be in this case. Well, actually, the best thing to do is, so which row of the table are we trying to figure out? We're trying to figure out this middle row, right? We're trying to figure out this change. That's what stoichiometry is good for. So our starting information should also come from the change row. I think you might have been trying to use the stoichiometric coefficients as the starting information. But remember, we're not actually starting with 3 moles of hydrogen, we're starting with 12 moles of hydrogen. Remember that this was just hypothetical information. What do we use these numbers for? We use them for making the conversion ratios. We've seen some examples where we use the stoichiometric coefficients to get the conversion ratios. In our conversion approach, we're converting one change into another change. So our target information should be something from this middle change row, and our starting information should always also be something from the middle change row. And that means it doesn't matter whether you use hydrogen or nitrogen because we have numbers for both of those. You could start with either hydrogen or ammonia now because we figured out numbers for both of those, so whichever you like. This is your work for that problem?
Yeah.
Okay, good. So we decided we're going to be using 12 moles of hydrogen gas. The stoichiometric coefficients say that there's 3 moles of hydrogen gas used for every 1 mole of nitrogen gas. So we end up with 4 moles of nitrogen gas used. You could just as well have figured that out from the ammonia. We're using 8 moles of ammonia, and we can see that we're going to use half as much nitrogen as the ammonia that we're making, and 4 is 1/2 of 8. You can work that out formally down here as well. Okay, so how much nitrogen will we have left at the end? Notice that we didn't figure this number directly from the conversion. We only figure out the changes directly from the conversion. This comes from the start change end table. Well, this shows that who is our limiting reagent here? The hydrogen, and who's in excess? The nitrogen. That's why, again, we can't just add these two numbers together. Where did this 24 come from? Well, this was telling us that if we used all 12 moles of nitrogen, we could make 24 moles of ammonia, but we're not going to be able to use all 12 moles. We're only going to be able to use 4 moles. We're only going to be able to use as much nitrogen as will react with the hydrogen. And we have enough hydrogen to make 8 moles of ammonia. So the actual amount of ammonia we're making is 8, just this number by itself. In fact, remember when we did our first example, I kind of briefly said that once you found the limiting reagent, maybe we should cross this version out, because this isn't actually going to happen. This could just confuse us. We don't actually have enough nitrogen. We don't actually have enough reagents to make 24 moles of ammonia. So maybe we should cross this out once we realize that this isn't leading us to the limiting reagent. All right, so this is a very important type of calculation, again, to be able to do quickly. Now, again, with practice, we should be able to figure out the limiting reagent here without doing this formally, mathematically. We're starting with the same amount of each starting material. But which starting material are we using up faster? So it should be clear that this is the limiting reagent, even without working through these conversions down here. And then you can immediately say that this is going to change by 12 and figure out what this change is going to be.